Let's continue with our second line of defense, internal defenses. We have two more topics to cover, antimicrobial proteins and fever. Antimicrobial proteins either directly attack the microorganism or block the microorganism's ability to reproduce. One of two ways. And the most important antimicrobial proteins are interferons and complement proteins. So let's start by looking with interferons. They're going to hinder the microorganism's ability to reproduce. So with interferons, we're interfering with specifically viral replication, preventing viruses from reproducing. Not specific viruses, just viruses in general, because what viruses do is they invade one of our cells. Since they cannot reproduce on their own, they need our cells' machinery to reproduce themselves. And then one virus comes in, many leave the cell, often destroying the cell while it does that. And these many viruses that have been replicated will attack other cells, and they start multiplying that way. So what interferon does is when a virus infects the cell, well, it's too late for that cell, but this cell that's been infected with the virus will secrete interferons, and interferons will go to neighboring cells, producing or stimulating production of specific proteins to block the viruses from entering. So although the first cell that was invaded by the virus it is not protected with interferons, but it's signaling its neighboring cells to produce these blockers, these antiviral proteins, to prevent the same fate from happening to those cells. Our other antimicrobial proteins is a whole system of proteins we call the complement system, with about 20 different plasma proteins that are in the blood, but they're inactive. When they become activated, they will perform or either enhance inflammation, and we went through what that does, or they will enhance our innate and adaptive defenses. So let's take a quick look at complement. So when complement becomes activated by any of these three ways, these inactive complement proteins in the blood will become active. And when they're active, just real simply, they'll either perform opsonization, which we've already covered. It's coating the pathogen surfaces, enhances phagocytosis from neutrophils and macrophages, or I should say, or enhances inflammation by stimulating histamine release that increases blood vessel permeability and attracts phagocytes to the area through chemotaxis. Finally, fever is abnormally high body temperature, but it's a response to invading microorganisms, and it occurs when our white blood cells and our macrophages are exposed to a foreign substance. And when they are exposed to something foreign, a pathogen, they secrete something called a pyrogen. Pyrogens go to the hypothalamus, that's where our body's thermostat is, which will raise the body temperature. Of course, a high fever can be dangerous, but a moderate fever is often beneficial to fight the infection because it starves the microorganisms of what they need to multiply, like iron and zinc, and it increases your metabolic rate, therefore the rate of repair.